Hey guys and gals, before we get started, there's a couple things that I want to make sure that I go over. Number one, you need a graphing calculator today, and we're going to go into mode and make sure this is set to degree and not radian. There's a way to do this. If you don't have one of these, there's a way to do this on your computer using the calculator, but we'll show you that a little bit later. So the other thing you need is a ruler or a straight edge of some sort. Lay out your page so you have a roughly a 1/4 inch. It looks crooked, but it's because of the angle of the video and everything. And and then put your title and everything. So we're going to talk about vectors today, and I'll use my little straight edge, and I'll say I didn't make that very straight, but let's see, this is April what is today's date? 15th. Okay. And then you can say 2021. Okay. All right. So what we want to do is we want to start off with a diagram, and I'm not going to write anything in here. I'm just going to draw the diagram first and just kind of discuss what's going on and all of the things that are going on with a vector. So our vector is literally the vector that we're working with is literally a force at an angle. Okay, so that's what our vector is. It's a force at an angle. So what I'm going to do is I'm just going to start, let's do this a little bit higher. I have a ball, okay? And this ball is being thrown. Now, we're not talking about trajectory. Trajectory is motion. We're just talking about an initial force that's put on this ball. So if somebody throws it or kicks it or whatever, you have an angle that it goes out. I'm going to actually use a straight edge here. I have an angle that it goes out, and this is actually a little steeper than the angle that I'm going to put. I'm going to put an arrow so I know what direction it's going. Okay? I don't know if I can zoom in. Yeah, look at that. I can zoom in. So, I've got my ball that's going out. I'm going to say at a force of 5. And I'm going to say this. Every single math teacher, physics teacher is always going to tell you to put it in newtons. I'm going to put it in pounds. And the reason pounds per inch or pounds per square inch or whatever, I'm just going to put LB. And here's why. We're going to do this with bridges, and we're not going to actually test it with newtons. We're going to test it with pounds. We're going to put pounds on our object, so we're going to use pounds per square inch. And I'm not going to write square inch every time. I'm just going to put LB. Okay, but I want you to understand that when I do this, I'm doing it as pounds per square inch of force. Okay? And then we have, and I need to create this line, because what I'm going to do is I'm going to give you an angle, okay? And I'm not going to do anything else right now, but this angle is going to be 30 degrees, okay? So I have a force of 5 pounds shooting off at 30 degrees, okay? So this is my vector. Now I have an angled vector that I need to break up into x and y values. So I have a force that's going this direction. I also have a force that is going in this direction. Now these are not the vector, they're just the components of the vector. So it is going, and what I don't know is how much force is being pushed in, or how much force is being pulled in the y direction and how much is pulled in the x direction. So I'm going to say x and y. Okay? This doesn't do a whole lot for me to be able to calculate it. Okay? So in order to calculate it, what I have to do is I have to turn this into a triangle. Because in order to calculate a vector, I need to have a triangle. And we're going to do it a special way. I'm going to just start here. And I'm going to call this B for ball. Okay? And now, at B, actually no, I'm going to put this up because you think it's point B. I'm going to call this B. Just B overall. Or I'll call this vector ball. That'll make it maybe a little bit easier to understand. So I have my vector that goes off this way. Okay, and I am going to call this vector B. And I'm going to put a little line over it to tell me that it is a vector. Equals 5. I'm just going to put 5. Don't worry about the units for now. I know that we're going with inches, and every science teacher, every physics teacher is going to be mad at me because they want you to do newtons. But now I'm going to do this the easy way. I'm going to put my x value. Give me a second. I'm trying to look. My head's in the way. But I'm going to make this dashed because I want you to understand that it is a component and not the vector. Okay? So I have my x value, so I'm going to call this bx. Okay? Then what I'm going to do is I'm going to close this in using a dashed line. And now I've got my y value, just like this. So it goes over x, up y, or it uses the vector. Okay? So then this is going to be by, b for ball, b for ball, b for ball. This is the vector, this is the x, this is the y. What I don't know is what this is, and I don't know what this is. But I do know that this is 30 degrees, this is 60 degrees, and because it's that way, I made these really small. I should have made them bigger so you could see them better. But because of that, I know this is 90 degrees. Okay? 90 degrees. I made this super, super small, and my apologies. I'll zoom in real quick just so you can see. Here is my ball being thrown at that angle. What it does after that is a different type of physics. But now we've got our vector. Okay? Pretty simple. So now, and this is the thing that I want to be very clear when I say this. We're going to use the law of sines. Okay? So, you know what I'm going to do? I'm going to go like this. And put a line across. So this is my diagram. We are, and for purposes of what we're doing and why, and we're not teaching physics. What I'm trying to show you is how to use the physics. So I want to make sure that everybody can do this math. I want to make it simple and easy and as non-complicated as possible. So we're going to use the law of sines. You can do something different if you want to. It doesn't matter to me. But I'm doing this just so I can help you individually with your math, and that way everybody is using the same method. Okay, so our law of sines looks like this. A equals, let's try that again. Sine A over A equals sine B over sine, or over B, excuse me, gosh, man, I'm getting ahead of myself. B equals sine C over C. So what I'm going to do now is I'm going to fill this in with the information that I know. Okay? And the way I'm going to do that is I'm going to do it piece by piece. So what I do know is I do know that B, our vector, I will change this up. So for this, maybe that's what I'll do. I'll do this. So we have, to make it a little bit less confusing, this should be sine b, and I'm going to put the line over it, over b equals the sine of bx over sine over b, over bx. And then this should equal also by, sine by over by. I don't know if it's, maybe I made that confusing by doing that, but I can use just x and vector or whatever. So what I do know is b equals 5, right? So I have this over this over this, and this over this, okay? So whenever you have a triangle, I should do that too. So I'm just going to do a little quick little triangle here. And it doesn't matter what the triangle looks like. This is a right triangle, but this works with any triangle that you're using. So this is, let's say, A. This is angle A. Angle A. Actually, you know what I'll do is I'll say A. So that matches up. This is B. That matches up. And C, and then those match up. Okay? All right, so what we have down here for our math for this is very, very simplistic, but what I have is, let's do sine 90 right here, sine 90 over 5. Okay, over 5 equals the sine, I'm just going to do the sine of bx over bx. Now, in order to solve this, we're going to cross these things across, cross multiply, and what we end up with, actually I shouldn't say equals. I should say, I'm just going to go over here, and I'm going to say, we're going to bring sine 90 down here, we're going to bring bx up here, we're going to bring 5 up here. So we have 5 sine bx. Yes. Well, actually, you know what I'm going to do is, for bx, let's do this 60, so I don't have to redo it. So I'll do sine 60. Sine 60. So then I have sine, because that way it's a little bit easier to understand. So sine 60. So I brought this up. This is sine 60. 5 times sine 60. 5 times sine 60 over sine 90. And what that did is then that brings bx out here, so I can say equals bx. Okay? So then I can say bx equals, and I can say clear on my calculator. I can say 5 times, it's not times, actually I'm just going to say 5 sine 60. And if you already know sine 90, I'm going to just do that just for you. Sine 90 is always equal to 1. So that's 4.33, let's say 01. So I'll say 4.3301. And that's my answer. So that is bx. So what I'm going to do is I'm just going to underline this. So you know bx is equal to 4.3301. I know that this is pretty close to being right because it's less than this number, which is the hypotenuse. The last thing I'm going to do, I'm going to come down here and I'm going to say sine 90 over 5 equals, and I'm going to come up here, so I've got sine 30 now is by. So sine 30 over by. Okay? So then cross multiplying, now I have 5 sine 30 divided by sine 90, which, remember, we decided equaled 1. Okay, I'm going to leave that off though. So then we have this is equal to by, and by equals, we don't know yet. So let's come over here to our calculator. We're going to say 5 sine 30 divided by 1, basically, so 2.5. 2.5, and it is pounds per square inch, or pounds, but that's alright. We'll just do this. And you know what? I meant to do this double underlined, so let's double underline. So that's our solution. That's it. That's very simple. All we're doing is we're taking our vector and separating it into its x and y values, okay, using the law of sines. Pretty simple. Okie dokie.